Okay, now we will go for the next reaction, benzoin condensation reaction. So we will see now where the carbanions is involved in these reactions. Again, we are going to use aromatic aldehyde in this reaction, and potassium cyanide as a catalyst to synthesize benzoin. Okay, so alpha hydroxy carbonyl group. So this is nothing but the benzoin condensation reaction. So what is the definition of benzoin condensation? Condensation reaction can be defined as the reaction between two kinds of aromatic aldehydes. Okay, two kinds of aromatic, especially benzaldehyde, in presence of some catalyst, either nucleophile or heterocyclic catalyst we can use to form aromatic parent compound. Okay, so to form this one compound. Condensation reactions are mainly used to create carbon to carbon bonds, polymers, new monomers, production of polypeptides, etc. Okay. Benzoin condensation reaction is nothing but the coupling reaction that occurs between aldehydes for the formation of parent benzoin. Okay. In this case, the benzaldehyde is involved in this homocoupling process. So we are going to couple 2 moles of benzaldehyde in presence of nucleophilic catalyst or heterocyclic catalyst to synthesize alpha hydroxy carbonyl compound that is called as benzoin. Okay, so we'll go for mechanism step by step. So step first is the formation of a cyanohydrin. So we are going to use the cyanide ion, okay, as a catalyst. So here you can see here is the cyanide ion acts as a nucleophilic catalyst, nucleophile, and we are going to do the nucleophilic attack. So in previous slide we have seen we have used the solvent system water plus ethanol. Okay, so it has some specific use of this water plus ethanol. Here you can see proton is abstracted from this blue colored solvent. So we'll see eventually that which solvent is providing this proton to this oxygen atom. Okay, so the first phase of the process includes the reaction of cyanide ions with the benzaldehyde. Okay, it's a nucleophilic addition across carbonyl group. It's a 1-2 addition. Okay, the sodium cyanide takes place in nucleophilic addition reaction, and it is a reversible reaction. The cyanide ion helps the reaction to occur by acting as a nucleophile and facilitating the abstraction of protons, thus forming cyanohydrin. Okay, so we got here cyanohydrin. Cyanohydrin means cyanide group and hydroxy group is present on the same carbon atom. That is nothing but the cyanohydrin. So first stage is formation of cyanohydrin from benzaldehyde and cyanide as a nucleophile. Okay, the cyanide acts as a serves as a catalyst in this reaction. Okay, so nucleophilic addition across carbonyl group, and once alkoxide will generated, that alkoxide abstracts proton from the water as a solvent. So here we got cyanide and hydroxy group on the same carbon atom is nothing but the cyanohydrin. So once we got cyanohydrin, second step will be the abstraction of proton from that benzaldehyde. Okay, so second step is the condensation reaction that occurs between the cyanohydrin and the benzaldehyde. Okay, so what is the condensation reaction? We'll see now. There is a formation of nucleophile from the cyanoid. So we have to generate the nucleophile from the cyanohydrin to acts as a nucleophile to attack on the second molecule of the benzaldehyde. Okay, so here we generated the nucleophile. Okay, so the cyanohydrin benzaldehyde, where the electron withdrawing nature of the catalyst comes into the play. Okay, so cyanide is electron withdrawing group, and this carbon nitrogen triple bond, this group acts as a resonance stabilizing group, and here you can see that one is this cyanide group is stabilizing the negative charge by forming resonance. Okay, so here is the resonance form, how they do form with this negative charge. Okay, so here by abstraction of proton by the hydroxide group, we have generated new carbanion here. So this carbanion is getting stabilized by delocalizing over this cyanide group. Okay, so delocalization of this negative charge occurs to form carbon-carbon double bond, carbon-nitrogen double bond, and negative charge is residing on nitrogen atom. So that's why we can say this carbanion is getting stabilized. Okay, resonance stabilized nucleophile we got, and the another important thing is polarity reversal or the prolong of the carbonyl. Normally, we would have significant partial positive charge on the carbon of the carbonyl. This means that the carbon atom in the carbon is typically electrophilic. Okay. So, however, in this case, we have a negative charge on carbon, making it nucleophilic. Okay, so we have nucleophilic carbon atom. This is polar inversion of the polarity we can see in this type of compound. Okay, so what is the third this one? So whatever generated, whatever nucleophile we have generated from the second stage, that one we are going to use now. So whatever carbanion generated, so we are going to utilize this carbanion as a nucleophile to attack on the second molecule of the benzaldehyde. Okay, so this one is also 1 2 addition across carbonyl group of the benzaldehyde. So 1 2 addition of carbonyl group, it gives this kind of intermediate. Several nucleophilic attacks are generally possible in this case. Okay, the formation of carbon-carbon single bond is the most thermodynamically stable. Okay, so this nitrogen also can attack on this carbon atom. Okay, this is also possible, but it's not thermodynamically favorable. Only the nucleophilic carbon attack, that is the thermodynamically favorable attack, and thus we are going to only look at the mechanistic step here. And this carbanion which is on carbon atom, that one is the mechanically favorable as well as thermodynamically stable. So in this way, formation of a new carbon-carbon single bond occurs via nucleophilic attack of this previous um, resonance stabilized nucleophile or carbanion, you can say. Next one, what is in fourth stage? In fourth stage, so whatever we got that intermediate after nucleophilic attack of this carbanion, this intermediate undergoes the dissociation, or leaving group leaves. Okay, hydrogen cyanide is leaving now from here now, so Cn minus is leaving to generate alpha hydroxy carbonyl compound. So in third phase, rearrangement occurs. Removal of cyanide ions occurs, resulting in the formation of benzoin. The rearrangement process results in the reverse of polarity of the carbonyl group, later adding to the second group of the carbonyl atom. The proton transfer in between the hydroxyl and alkoxide. This proton transfer occurs from the hydroxyl group from the alkoxide and pushing the leaving group out. Okay, pushing the leaving group out. So in this way, abstraction of proton, or rearrangement of this proton and leaving group, elimination of this leaving group generates the benzoin. Okay, so in this way, last stage is the formation of benzoin via leaving group dissociation. So in this way, we got the benzoin as a product. This is the total overall mechanism of the benzoin condensation reaction. So you can utilize this thing for your final examination. Also, I tried to represent by another way. This is also one more mechanistic steps. You can refer either previous one or this one for your final examinations. Okay, so Pulang concept, where is the Pulang, how that one is attacking. So everything I have mentioned over here. So use that one. One more thing we have generated. We have generated this carbon-carbon single bond. That means we have generated one new cyclic ring here by utilizing two different aldehydes. This is 2-methoxybenzaldehyde, and this one is another kind of aldehyde, aromatic aldehyde, another kind of aldehyde. In place of catalyst, which new bond is forming, they have given over here. Okay, so new, this one is new bonding what they form by utilizing this aldehyde and 1,2-diketone or ketoester in place of catalyst. How to generate new bond? Again, the same 1 mole of aldehyde and 1 mole of ketone. By utilizing this one, we can generate this type of new bond. The same things, that means comes under the this reaction. So two moles of this one, this molecule paramethoxybenzaldehyde in place of potential and heat it on water, we can generate this type of benzoin. Okay, 2 moles of furfuranaldehyde we can utilize and we can get this bit alpha hydroxy ketone, and these are the examples of the benzoin condensation reaction. Hope this one will help you out for your final examination.